Hello, this video will show you one way that you can determine the area of any given parallelogram. First, let's review some important terms. A parallelogram is a quadrilateral or four-sided shape in which each pair of opposite sides is parallel. The area of a shape is a measurement of the region bounded by a closed plane, or in other words, the area within the lines of a shape. Now let's look at parallelogram A, B, C, D. Based on the definition of a parallelogram, we know that AB and DC are parallel. We also know that AD and BC are parallel. Another characterization of a parallelogram is that adjacent angles are supplementary or add up to 180 degrees. So we know that angle ADC and angle DCB are supplementary. The formula that we will use to find the area of parallelogram ABCD is area equals base times height. The base of a parallelogram is typically the longer pair of sides of the quadrilateral. Usually, we'll pick the bottom side as it is the base or foundation of the shape. So with our parallelogram ABCD, our base DC is 10 centimeters long. Now let's find the height of the parallelogram. One important thing to remember is that the height of a parallelogram must be perpendicular to the base. The height is the altitude of the parallelogram and can be placed anywhere inside or outside of the parallelogram as long as it is perpendicular to the base. With parallelogram ABCD, the height is 4 centimeters. Let's plug in the information that we found into the area formula. Parallelogram ABCD's base is 10 centimeters and its height is 4 centimeters. What is the area of parallelogram ABCD? If you calculated that the area of the parallelogram was 40 centimeters squared, then high five a friend. Let's look back at the equation. The area is 10 centimeters times 4 centimeters. 10 times 4 is 40, and we need to remember to square our units because we're finding the area of something. So the area of parallelogram ABCD is 40 centimeters squared. What I do next may help you visualize why the area formula for a parallelogram is base times height. When I placed the line for height on parallelogram ABCD, I created a triangle. I'll make the triangle blue so it's easier to see. Because angle ADC and angle DCB are supplementary, I'll lift up my triangle that contains angle ADC and connect it to angle BCD on the other side of the parallelogram. Now we have rectangle ABCD with a height of 4 centimeters, a length of 10 centimeters, and an area of 40 centimeters squared. When we use the area formula for a parallelogram, we are actually calculating the area as if the parallelogram was a rectangle.